Thank you for coming to this session, guys. You'll be forgiven for thinking that this is a session about the GoLang programming language with that title, spelled like that, but it's in fact about InterSystems Kubernetes Operator. Go language does fit into this because from the Docker days and Kubernetes and many of the tools within this arena are actually written in Go, but it's not about that. We're going to talk about IKO. I'm going to share the stage today with Steven Lubars, a manager of a talented group of developers that we have at InterSystems, where we're trying to build the next cloud fabric for InterSystems, and Joost Platenburg, that comes from the Netherlands to share his experience with IKO. I've left the name Ari Glikman in there because Ari did help us with some of the slides, and he was supposed to present here, but unfortunately stuck at home because he lives in Israel, and Ben Gurion airport is blocked, as you probably know, because of recent event. So without any further ado, let's go ahead. The agenda is very simple, a little introduction, then the meat of the presentation on IKO, best practices, tips and tricks, and new features of IKO. Then we're going to talk about governance, and then we leave the stage to Joost. All right, so Kubernetes was defined as the cloud operating systems, and IKO is here to help you deal with stateful services within that. And so that's what we're going to talk about today. So what's the context within, the market out there? Well, the market says that, at least from a recent survey from the CNCF Cloud Native Computer Foundation, 80% of IT professionals have Kubernetes clusters in production. Okay, and if that wasn't enough, more than 50% or respondent to the same surveys, have containerized workload one way or another. The number of containers being managed by these orchestrators have doubled in the last couple of years as well. And also the economics on the last dots, as you can see, are very interesting. Depending on the survey that you look, is between 2 to 9 billion projected growth. So it's definitely something that's here to stay with us. And so within this arena, for those that were here from the previous presentation where IKO was introduced with some of the features, I'm going to hand it over to Steven Lubars, that's going to take us through some of the new features and gotchas. Thank you, Steven.
Hi, thanks, Luca. So, Kubernetes is very powerful, but it's also quite complex. And two of the challenges of deploying your application with Kubernetes, one is there's a lot of resources to manage. And let me go to this illustration of resources. And the other challenge is that Kubernetes doesn't know anything about your application. For example, Iris. It doesn't know about ECP clients or widge volumes or Iris CPF files or anything like that. So the answer is to create a Kubernetes operator. And what an operator does is it introduces a new native Kubernetes type that manages the life cycle of your resources and understands your application. And the operator we've created, the Iris Kubernetes operator, introduces kind Iris cluster. And it provides a concise, intuitive way to describe your Iris deployment. And this is a very simple deployment here, but it's complete and valid. It's a single non-mirrored Iris instance with a single external IP address. But even what you're seeing here has thousands of lines of vanilla Kubernetes behind it. You could write that yourself, but it would be very difficult to understand and maintain, and it would not be able to accommodate different configurations easily. An important aspect of a good operator is it doesn't restrict you just to the fields that we've provided here. You still have the ability to override and extend it with vanilla Kubernetes when needed. And that's actually the subject of this talk, is when the out-of-the-box defaults are not sufficient. Situations we've encountered in the field where you do need to add something extra to your configuration. First I want to talk about is the preferred zones field we provide. A lot of users want to reap the benefits of HA, so they enable mirroring to create a failover pair in Kubernetes. But Kubernetes is perfectly happy to put both of your instances in the same data center, in the same rack, even on the same machine, which doesn't really get you a lot of HA, or at least not as much HA as you might be hoping for. So a better strategy is to distribute your instances across availability zones. And all the major cloud providers supply availability zones, which guarantee they're going to be spaced apart by tens or hundreds of miles, and definitely not be in the same data center. So you definitely want to use preferred zones when you're using mirroring. And you want to go one step beyond that. You probably want to put your arbiter in a third availability zone. Because if you think about it, the arbiter's role is to provide an objective determination of whether the primary is available. If you put your arbiter in the zone of the primary, whatever fate has befallen your primary might affect the arbiter as well. And if you put the arbiter in the zone of the backup, then it's no better situated to determine the state of the primary than the backup. So that's our another recommendation we have. Just to illustrate what I was talking about before with the amount of vanilla Kubernetes behind some of these intuitive fields we've added, this is just a small slice of the code behind this preferred zones field in vanilla Kubernetes. That first block says, which is node affinity, says that all the nodes must be restricted to the zones we've listed. But even here, Kubernetes is perfectly happy to put both instances on, say, in zone B. The second block is pod anti-affinity, and it's saying that the instances should be on different hosts. And the third anti-affinity block is saying that the hosts should be in different zones. So just an example of some of the code that is behind the fields you see in IKO. Next, crash loop backoff. If something goes really wrong with your container, hopefully not wrong with Iris, maybe a customization you've made, a %z start routine, some other configuration problem. If Iris exits, the pod will exit, and then it'll restart and exit again, and it'll start and exit over and over again until it enters the Kubernetes state, crash loop backoff. And in this state, it's very difficult to debug anything. You can't open a shell, you can't look at logs. So the way to break out of this situation is to use a snippet of vanilla Kubernetes here, a pod template spec, where we're overriding 2 of the command line arguments to the Iris entry point application. The --up command line option says whether or not to start Iris with the pod. By default, it's true. So restart the pod with this parameter set to false. So the pod will come up, Iris will be down. You can attach to the instance, you can look at logs, you can perform a restore, you can tweak your scripts, manually start Iris. And once you've worked out those issues, revert that argument, hopefully make the changes back to your original Docker image, and the pod should come up normally. Next, the compatibility version field. Multiple versions of IKO work against multiple versions of Iris. The trick here is, though, that each version of Iris may have slightly different configuration file formats. Iris CPF file, properties change, parameters change. There's also for web gateway, the csp.ini file. And IKO needs to know what version of these configuration files to generate. It tries to make an educated guess based on the tag of your Iris image, but that's not always successful, especially if you've customized the Iris image and made up your own tag. So in those cases, and you're going to see some strange errors in the log. You're going to see unknown property, invalid CPF parameter. It's going to be a big kind of mess. So when that happens, you should put in an explicit compatibility version that you know corresponds to the underlying version of Iris that you're deploying. Next, Iris FS groups. The Iris container does not run as root. It runs as user Iris owner in group Iris owner, which is a good thing. But by default, Kubernetes mounts all volumes as root, which means that by default, Iris will not be able to read or write to the volumes it's mounted. So to get around that, IKO creates what's called an init container. It's a container that runs before Iris. It does run as root, and all it does is change the ownership and permissions and group of the mounted volumes to be Iris owner. Then it exits, Iris comes up, and it's able to access those. But some of our clients aren't allowed to run anything as root, not even their init container. And if you can't run your init container as root, you can't use this method. If you go into our Helm chart for IKO, in the file values.yaml, you'll see a bunch of parameters, including use Iris FS group. If you flip that parameter to true, that tells Kubernetes to mount all volumes with group Iris owner instead of root. And then IKO will suppress creation of those init containers, and you'll have nothing running as root. Bring your own registry. So if you've visited containers.intersystems.com, you'll see that the images we list there only have the major and minor version, for example, 2025.1. This always is going to link to the actual latest release of Iris. It could be 2025.1, .1, .0, .1, .2, and we tend to update these with each patch release, often for security patches or other bug fixes. The problem is if you directly link to these in your YAML, you could get a surprise upgrade, and it could be an unpleasant one. In other words, you've directly linked to containers.intersystems.com 2025.1. We've updated that from 2025.1.0 to 2025.1.1. Then you make some trivial change to your configuration, totally unrelated to the Iris image, update, and suddenly you've triggered a rolling update of your entire deployment. At best, a surprise with some unexpected downtime. At worst, you could be down for the count because that upgrade could fail. If Iris doesn't come down cleanly for whatever reason, upgrade won't proceed, and you're kind of in a world of hurt. So our recommendation here is do not link directly to our registry. Pull down these images, push them into your own registry, a private one or one of the many third-party registries out there, and link to that instead. Then you'll have no surprise upgrades. Quality of service. By default, Iris runs with the lowest quality of service, which is best effort. Best effort means that any other pod that needs resources, CPU or memory, can evict the Iris pod, which is a bad thing. Best effort pods can be evicted by burstable or guaranteed pods. To be a burstable pod, you need to specify a request in your YAML, a CPU request and a memory request. But you can still be evicted by a guaranteed pod. To be guaranteed, you need to provide both. And there's a snippet here showing a pod template spec added to the IKO YAML with both requests and limits. And if you specify both, and the limit, think of it more as a minimum, that places you into the category of guaranteed. And I'm guessing for the majority of you, you do want your Iris pods to have guaranteed quality of service. Load balancers. The load balancer that comes with IKO is a very simple one. It's an application load balancer, provides access to web gateway, to your management portal, but may not be sufficient for your needs. It doesn't. None of the cloud providers' load balancers provide a health check path. They don't do TCP/IP. We had one client who had a legacy application on-prem. It was, I think, an HL7 version 2 application that needed communicated by a socket, and they moved to the cloud, and they were like, how do we talk to it? And the answer is go ahead and create additional load balancers. Create a network load balancer, add whatever rules there you need or want to. So the message here is it's not either or, it's both and. You can, the application load balancer that comes with IKO is not sufficient for your needs. Certainly add your own. Nothing to prevent that. And finally, a few other fields you may find that you need to use. If the preferred zones is insufficient because you're deploying an environment that doesn't use zones, you can provide topology spread constraints and describe how you want your pods distributed across nodes. If you've added applications to your iris image that require more time to start up or have more work to do before you're ready to accept data, you can override the readiness probe and liveness probe that come with IKO. Update strategy, by default, rolling update. You do an update, it's going to update every single pod you have in reverse order. That may be undesirable. If you want more control over how updates work, you may want to change the update strategy to on delete. On delete gives you a chance to explicitly decide which pods to upgrade in which order. For example, you may not want to upgrade your mirror primary until you've verified that the backup is ready to take over. Finally, containers. If you want to add your own sidecar containers, you're completely free to. We've parameterized the web gateway container sidecar in IKO to just require only one line of code. But if you already have other containers you need to run, there's a containers field you can certainly override in the IKO specification. I think that's about it. All right, thank you.
Thank you, Stephen, for all the details, new features and gotchas. Okay, and this second part, we're going to talk about governance, because there are obviously challenges when we work with Kubernetes, but I think that there are more challenges when we realize that we have other issues coming up, which is the fact that when I run a single Kubernetes cluster, maybe one of my developers says, hey, I want one too. Oh, don't we want to create one for testing? What about preview? What about user accepted testing? What about live for my customer in Europe? And what about live for my customer in Australia? And so we have this sprawling of number of Kubernetes clusters out there, which obviously pose a problem, right? And in general, it's all about governance, right? Even with a single cluster. And so it is about management, the security, the risk mitigations. And what we are saying basically here is that the environment, even a single environment, is complex by itself. This is going to be multiplied by the numbers, of different classes that you have. And so as we look at having all these decentralized data plane clusters, I think it's the time for us to consider that a centralized governance system is probably very useful. By the way, how many of you are using Kubernetes here this session? All right, we've got a few hands up. Okay, so hopefully you can relate to all these issues. So can we put the fun back in working with Kubernetes? Well, the idea here is that there are tools out there that actually allows us to have a control, infrastructure, automation and orchestration, governance over decentralized, rumote clusters. And let me just mention Crossplane, for example, probably one of the first one. Very interesting. It runs with Terraform underneath it. Personally, I found it very heavy when I tested it. But there's lots of others like Karmada and Cordant. But one of the things that you notice when you start looking at this world is that there are special interest groups within the CNCF organization that are actually already looking at this. And so one of the projects that we have there is the Cluster API, or CAPI for short. And Arancha, for example, already support the CAPI. the copy controllers. And what this allows you to have is basically this centralized Kubernetes cluster that you use as the control plane, as the conductor that allows you to really implement rules, policies, and requirements across all your decentralized multiple Kubernetes cluster that you may have. So my premise here, my hypothesis is that by using a centralized control plane, if you like, you are actually able to have a cluster, much better governance of it all. So let's go and have a look at what we have. So one part of the governance that we need to adhere to are all those rules, all those policies, those ordinances that we are told that we need to adhere to. And so I picked up the last one that we have in Europe called the DORA, which is not a cartoon like I saw on the passing through the airport the other day, but it stands for Digital Operational Resiliency Act. And basically in Europe, they are tired of seeing it's only for the financial institutions. They're tired of seeing financial institutions that only set aside capital to offset risk. They said, no, you need to come up to speed and do things properly. And so there are quite strict and important regulation now that you must have had implemented already by the end of January of this year. I don't know how many of them have it, but anyway. So I picked up DORA and I said, okay, can we be resilient operationally here with Kubernetes? And this is my hypothesis here that says, if you're working with Kubernetes, you actually have a great companion that actually supports you in compliancy, in this type of compliancy. So let's go through these 4 slides. So the first is risk management. Well, because we use infrastructure as code, all right, by default, we reduce the risk of misconfiguration. Automation of scaling and failover, well, this is native, right, within Kubernetes. If then you have things like the Kubernetes Operator and RS mirroring, then all the better, you have better RPO and RTO, but it is native within the platform itself. In terms of network policies and RBAC, again, there's our RBAC policy within the Kubernetes itself, and in terms of network, all network layers that you might want to use, like Itzos, Cilium, Linkerd, they all have the capacity, the ability for you to define policies. So again, they're all very native and within the Kubernetes environment. In terms of backup, where you can start, backing up a single file, single .dat, even with InterSystems READY new backup features, or use some open source solution, and you can, back up whatever you want, even the whole cluster with tools like Velero. Let's have a look at detection and response to incident. Centralized observability, we're told. Well, we've seen from the previous session here that even InterSystems READY support OpenTelemetry, and therefore, any tool that you might want to plug into that chain, sysdig and Datadog and the Prometheus and Grafana's of this world, they all support this new protocol. So it is available there. And some of these tools are, CNCF native project. So again, you play within, a very natural environment here. What about policy enforcement? Well, you have the Kubernetes admin controller. You also have things like the open policy gatekeeper there, or tools like Kyverno that allows you to really define, all kind of policies within Kubernetes. So again, they're all native tools that fits very well within the environment. What about immutable deployments? Well, by default, that is native, right? You get this container that we've been talking about, previous session, this session. It is an immutable artifact that you want to run. And in terms of event-driven incidents, Kubernetes itself, has this as a native solution. We've seen from Stephen before. You can look at failing over on different availability zone, and therefore, again, it's a good companion to have Kubernetes to support these policies. What about stability Well, we know from the days of initial, Netflix, Chaos Monkey. Now these tools are also, available within this environment. And just like any environment, this could be also bare metal or VM, right? It's something that we need to stress and make sure that we're able to, to simulate failures. For load and stress testing, well, you can talk to any of our technology architects, and the answer is always the same, right? You need to test, test, and test. It depends on your workload, depends on the type of resources that you use in the cloud, and therefore, these two bullets are the same as with any kind of architecture. In terms of cluster redundancy and failover, instead, we know that by default it's native offered by Kubernetes itself, so you can work with another availability zone naturally. Again, if you use InterSystems IKO, you just put that boolean yes, you can get mirroring for free, or very, in a very convenient way, and again, it's all native part of Kubernetes. What about third-party, external dependency, extra libraries? Well, we need to start looking at, Gartner calls it the infrastructure orchestration, infrastructure automation and orchestration. They have a full, report on this area. And so we need to start looking at the whole pipeline from the moment the developer, checking his code, and start getting used to see the whole supply chain here. So, maybe have a look at the SALSER standard. But, the other important thing here is going back to the way Kubernetes works. We got, a full bill of material there right in front of our eyes, because it is defined in those famous YAMLs typically. And so, even in regulated environment, we've got the ability to really say, yeah, I can more easily, with this type of environment, support a full supply chain for the whole path. Of course, it goes without saying that our images needs to be scanned. Lots of tools there available. And in terms of policy-driven GitOps, there are native tools that you can use, like Argo CD, Sveltos, Flux, that allows you to really embrace totally GitOps type of policy and approach. So my last slide is to confirm my premises that we could have a control plane as a single, small, perhaps Kubernetes environment that actually helps us to orchestrate decentralized, data planes that we have across the clouds. And of course, you won't be able to do that just on its own. You have to probably have corollary systems like Argo and Sveltos, and of course let's sprinkle a little bit of AI there. There are already 3 or 4 tools that you can use that can help you in managing and assisting you in working with Kubernetes like that. And so as a summary, to have a single conductor does help you, makes things more efficient in terms of risk management, in terms of efficiency, in terms of supporting the policy that can come from anywhere. And with this, I finish this part on governance, and I'm going to leave it to Joost Platenburg. He's going to tell us about his experience with IKO.
Good afternoon. First, I always wanted to do this. By show of hands, how many of you already deploy on a containerized platform? Okay. Then this will be more or less new for a lot of you. A little bit about myself. I'm Joost Platenburg, Enterprise Architect with KPN Health. KPN Health is a part of KPN, which is the largest IT company. No, not IT company.
The microphone is here.
Oh, sorry. Is the leading telecom provider in the Netherlands. It specializes in the infrastructure and mobile and fixed networks for internet and TV. In the early 2022, they wanted to share their market presence in the KPN Health environment, and they bought a company where I worked for, Itzos. The newly formed company KPN Health, where we became part for had a first tender that was for Koppeltaal 2.0 in Dutch. Koppeltaal 2.0 is an interoperability platform for mainly mental health care systems, and it is fully FHIR-based, and it is an improved security and compliance compared to the 1.0 version. One of the most important criteria or demands in that tender was that it should be deployed on a containerized platform, which was strange because the company that wrote out the tender is not an IT company, so it is very peculiar that they asked for such a specific platform. Problem there was that KPN did not have the expertise at that time to deploy such systems. And we used a partner from KPN to implement the Kubernetes platform. What they did was they created 2 clusters for tooling, which they learned us a lot about. That was the Argo toolset, and Trivi and Grafana for monitoring. And per large customer, they deployed 3 clusters in a OTAP, or DTAP, as you call in America, street. One other thing they gave us was a CI/CD process which they had created, which was based on the tools that they deployed for us and GitHub release management. On a branch in GitHub, we create a release. That release triggers an event, an Argo event, which in its turn creates a workflow, Argo workflow, and that workflow builds an image, the image with the release that was taken from GitHub. After it builds that image, it puts it in the local image repository, and it updates the Helm charts that were created earlier. And by Argo CD, the system is synchronized with the production system. This worked fine for us. It worked fine up until that we found out about IKO. The first process was based on Helm charts, and the Helm charts were rather complex to manage. Certainly when we learned about IKO, which made it very much easier to do so. One of the things that IKO learned us was, now let's first tell you something else. What we did at that time was simply, we were a virtual machine company, so we had lots of images or machines running VMs. And we thought that Kubernetes or containers were just VMs on a containerized platform. So what we did was we took the, say, image from the virtual machine, put it in a container and run it on Kubernetes. That worked, it runs, but you don't take advantage of all the good stuff from Kubernetes. One of the good things that we needed was the availability of horizontal pod autoscaling. That's the horizontal scaling by creating more than one pod to run your systems in. That was new for us. Thing is that to do so, we had to redesign the systems because we had to split the web applications and the data nodes, which are not split. Sorry, I have very dry mouth. So we had to redesign the systems to split the data and the computes. Once we did that, it was easy to create a horizontal pod scaling on the compute nodes. Why is it necessary to split that? Because the horizontal scaling is only possible on compute nodes and not on data nodes. data nodes are single, except for the fact that it's very easy to create a mirror. Once you have a mirror, you have the possibility to update without downtime. Zero downtime updates are then possible because all your systems are at least double. Currently, all our systems are run from IKO. IKO is very much easier than help charts. It's less, it's compact, and it's just one manifest that you have to create and maintain. We have several systems. Some of them request scaling, horizontal scaling. And if that's so, then we create a compute node with a horizontal pod autoscale section in it, and it works perfectly. Vertical scaling was also very new to us. Vertical scaling being the use of variable CPU and memory resources. You create with a requested number of CPUs and memory, and the system takes what it needs from the central pool of resources up until the maximum that you have assigned to it. Thing that I just learned from Bob in the back is that ECP, the Enterprise Cache Protocol for writing data to the data node, is, how do I say, not encouraged by InterSystems to be used with interoperability production. If you want specifics of the interoperability production as first in, first out, or queuing mechanisms and stuff like that, you cannot put that in the data node. You have to keep that on the compute node. The compute node being the node where the production is run. I told you about the zero downtime updates was important. One of the other things was that without IKO, we tried to implement something like IAM. IAM Kong is an API manager. And without the IKO, that is, for us, was very hard to do. So we only started to succeed in using the IAM after we used IKO. And now all our services are deployed through a Kong API manager. Now comes the technical picture. This is practically unreadable, I know, but this is one of our systems that is what we consider rather complex. It's keep forgetting the microphone. It's a publish and subscribe mechanism where the blue on the left are the publishers. They search for events in HR systems like joiners, movers, leavers, and they trigger an event in the core. That's the pink box over there, and there is a queue where subscribers, the yellow boxes, can subscribe to. Each of those boxes is an iris cluster with a separate IKO manifest in one project. The reason I put this picture in is because the presentation is distributed so you can have a closer look. But also to show that there are systems here that have a loose data node. That is necessary because on the compute node we want horizontal pod scaling, but horizontal pod scaling can only be deployed on compute nodes and not on data nodes. But you need to have a data node because IKO only works with at least one data node. Therefore we have just data nodes doing nothing. That pink box that you saw there, that was the heart of the system that I showed. And it's IKO manifest, as we call it. I don't know how it's called officially, but this is how it's configured in IKO. I don't know if I need to go on line by line, but this is what it is. Last slide, in conclusion. Of course, we did not completely switch from virtual machines to Kubernetes. We have a mixed environment. We need to, because we also have health share systems, and health share systems do not run on Kubernetes. In those systems where we use health share, we have services that are needed to run the health share thing, and those are run on Kubernetes. So we have a truly hybrid environment. Using IKO on Kubernetes is a must for us, because Helm is just very confusing, and IKO makes it very easy to deploy InterSystems systems on Kubernetes. And of course, if you are starting, do not just take a VM image and put it in a container, because that is not good. That's not using the true strength of Kubernetes. Less than 5 minutes left for questions. That was not yet. The one.
Thank you, Joost. Interesting stuff there. To connect with us and carry on the discussion, if you want to reach out to us, you got our emails. You can come and see us at the Tech Exchange for demos, Capi, IKO 3.0, 3.9, whatever. It's been the main developers. We actually launched it at Global Summit 2019 in Boston, if you were around. And what else? Yes, please don't forget to run the survey on your app. And the early access program is this quick QR code that you don't have time to get your phone out for, but you know that you have that possibility. Thank you very much. We've got a few minutes left, 3.5 minutes left, if anybody has got any question.
Hello? Okay. Yeah, so in IKO, is there a way, you know how we have data nodes that they're mirrored, right? So, but each pod has its own file system, its own PVC that's mounted. Does IKO have the capability of creating or configuring a shared file system between the two, so that in case that one fails over, if there are some files that you have in one, can still be accessible in the backup?
So you're asking if you could have test. You're asking if you could have a mirror where both members share a volume so that at failover the data is available on the backup? Well, no. That would sort of defeat, I think, in some sense, the idea of, I mean, the purpose of mirroring is to make sure that the backup has a volume with the same data as the primary, and that if something happens to the primary, including, you know, a asteroid destroys the disk, that the data is still intact somewhere else. So.
Yeah, from a database perspective, that's good. But if you're in the middle of processing some, let's say, files, right? We have interrupt productions running in the data node. Let's say we've pulled in some files, and now we're ingesting them, processing, and something happens to the primary, and it fails over. Now those files are sitting, right, in the failed node. Database, everything's running fine on the backup, but there's no way for those files to be accessed.
Yeah, that's a case where I think you need to write code that recognizes that a send or a store operation or interoperability operation failed, and you'll need to retry and have it directed to the new primary.
Yeah. Are you referring to NFS type of volumes, basically, so you can share them between?
Yeah, so NFS, or like, for example, we use Google Cloud, so now Google allows the functionality of mounting GCS storage to pods. So yeah, we could maybe configure something there, but I was just asking if there was anything in IKO or in the roadmap that would allow to using, the orchestrator, the Kubernetes orchestrator, to kind of simplify that task if there was anything out there already.
I think it's a good requirement. It has come up before. Yeah, so definitely something that we need to think about. Yeah, thank you.
Thank you.
Appreciate it. I think there was one in front here.
No, I was just gonna say to that question that I think we have a similar use case where we have a shared volume in addition to the data volumes, where we have files that either the primary or the backup, they can access the same files.
Yeah, I was going to answer like that, but he was specifically asking for kind of IKO help. So, yeah.
You can create volume claims that are available to different instances and different IKO clusters that will attempt to mount the same volume. But you're going to get, if more than one of them is read-write, I think you're going to get an error. So one can be read-write and the other is read-only. So it's certainly possible to have multiple instances mounting the same volume. But with different mount paths, with different subpaths, directory subpaths, or to the same directory subpath?
No, I think it's mounting a shared volume, PVC claim. I don't think there's anything fancy to it, just it can be mounted as write many.
I've encountered errors mounting multiple claims as write many with the same directory subpath, but I could be wrong. There may just be features of the or attributes of the mount I'm not exercising properly. So that's a good requirement for us to think about.
Any other question? Nope. Okay. Well, thank you everybody for being here.